The Mini 3 Pro is an excellent drone, but signal transmission has always been its weak point. In this video we will find out if the signal strength has improved significantly in the Mini 4 Pro. The signal quality for the same drone may vary according to the geographic location. Important difference exists between the transmission modes used in the US, the FCC, and the one used in Europe, CE. In most cases, FCC mode delivers a stronger signal and increased range. Within the same continent, the strength of the signal also depends on interferences and congestion of the lines, with rural areas performing better than urban ones. DJI has acknowledged the issue with the Mini 3 Pro and has taken action in 3 different directions to improve the signal of the new model, the Mini 4 Pro. Previous DJI lightweight models, the Mini and the Mini 2, have a pair of small feet at the end of the forward wings to facilitate landing and to house the antennas in a vertical orientation. The design of the Mini 3 Pro has got rid of the feet, and the antennas are placed inside the wing horizontally. According to many users, the position of the antenna is a major cause of the poor signal of this model. A few months later, DJI released a cheaper version, simply named Mini 3. In this model, the classic wing design was restored, with vertical antennas again inside the feet. The signal transmission of the more affordable model is noticeably better than the one of the Mini 3 Pro. So, for the Mini 4 Pro and Air 3, DJI has again adopted the classic design, with antennas in the front feet. The Mini 4 Pro and Air 3 are offered with a new pair of remote controllers, the RC2 and RCN2. This was a surprise move, as the previous controllers, the RC and RCN1, were released together with the Mini 3 Pro only 1 year before. The main difference is the presence of the pair of extra antennas in the new models, doubling the number of both receiver and transmitter antennas to enhance signal strength and transmission performance. The Mini 4 Pro, like the Air 3, has a new transmission system, OcuSync 4, which supports a new frequency band of 5.1 GHz, besides the 2 traditional ones, 2.4 and 5.8. The new band, which is more precisely between 5.17 and 5.25, is particularly interesting for users based in Europe, as it should offer a more powerful signal with very low traffic. The drone with the best signal transmission I ever tried is the Hotel Nano Plus, which has indeed the third 5.1 GHz band. The maximum transmission distance announced by DJI in area unobstructed, free of interference, is 20 km in FCC mode for the US and 10 km in CE mode for Europe. These distances are nowhere near what can be reached in real life. DJI also gives distances for areas obstructed and with interference with a range between 0.5 and 3 km, according to the nature of the obstructions. This is much closer to what we should expect. I'm not interested into testing the maximum range of the drone by flying several kilometers away for several reasons. It is against the rule, as we are supposed to keep the aircraft within line of sight. It is dangerous, boring, and not useful. I don't need to smuggle objects into other countries. I do not recommend doing this sort of tests, as it's very easy to lose your beloved drone. I would be very happy with a model that can operate in most environments in a range of a bit less than a kilometer or 3000 feet, without any disconnections, latency, or loss of signal. I have tested the 2 models in the same areas. The first one is in East Sicily, between Mount Etna and the Mediterranean Sea, with several little villages in close succession. There are houses and cars all around. There are also some big telecommunication antennas, so it is an area with extreme interferences. All the tests were done with very low wind. Let's start by going east towards the sea. Besides the strong interferences, the itinerary is relatively obstructed, as there are a few trees between me and the target. I will be trying to film 4 interesting small volcanic islands just off the coast. First of all, let's see how the Mini 3 Pro behaves with the RC controller, the previous version with a built-in screen and without external aerials. After only 70 meters, the signals start to worsen and the bars turn to yellow, which is not at all a good omen. I increased the elevation to improve signal quality. At around 170 meters, the signal goes down a lot. At 200 meters, the bars turn red, meaning that a disconnection is going to happen soon. After several warnings, the aircraft manages somehow to get to 430 meters, where a return to home is initiated. I have tried the Mini 3 Pro with the RCN1 controller, which has external antennas in the clamp holding the remote device. The result was slightly better, confirming that the controller's lack of internal aerials it is a negative factor. Let's have a go with the Mini 4 Pro with the RC2 controller. In the transmission tab of settings, if we set the frequency to dual band, the one chosen is constantly the 5.1 GHz, and this makes sense, as it is supposed to be the best performing one here in Europe. So I select dual band. We can now advance towards our target. After about 300 meters, I raise the maximum altitude to visualize our target, the 4 tiny islands. At 420 meters I lose the first bar, but we are still in the white, which is good. At 500 meters the bars turn to yellow, and the signals start to deteriorate. At 620 meters the bars turn to red, and I get finally disconnected just above 700 meters. The result is a huge improvement compared to the Mini 3 Pro. I'm quite happy with it, considering the major interference and the partial obstruction. I managed to have a decent view of the small islands. This time, starting from the same point, I head north, keeping the sea to the right and Mount Etna to the left. It is again a very populated area, heading towards a relatively big town, so the interferences are still quite strong, but not as bad as the previous itinerary, as we are moving away from the big transmission antennas. There are practically no obstructions between the controller and the aircraft. I keep going and I still have full white bars after 500 meters. Same at 600 and 700. I lose the first bar just for a few seconds before 800 meters. I still have full bars and an excellent signal at 950 meters, and I stop here as I'm not interested in going any further. Probably I could have kept going for a lot more. This is an excellent result considering the interferences. But what about flying in a rural environment without any interference? So I packed the drone and controller and head to Mount Etna, in a very remote area with no buildings. Surely I should get a better range. I start with the Mini 3 Pro with the RC controller. I set the transmission to dual band and I'm ready to go. There is nothing around, we are in the middle of nowhere. We should have no interference at all. I start flying in the direction of these old craters and I lose a few bars at a distance of 200 meters. At 320 the bars turn red, which is not a nice sight. I raise the altitude and the bars go back to yellow. Then back to red at 500 meters. I manage to reach 700 meters before I get disconnected. It is the worst performance in this sort of environment in any drone I've tried, but it is still a distance that suits my needs on most occasions. And now the Mini 4 Pro with the RC2 controller, around the same area up on the volcano. The drone keeps going and going without any hesitation. It maintains full white bars for the whole journey. Doesn't drop even a single one until reaching 1 kilometer. It would have certainly kept going for much longer. So, with the Mini 4 Pro, DJI has addressed and solved the transmission issue of the Mini 3 Pro. This is something to keep in mind when planning to buy one of the two models, at least for users based in Europe. Click on this link to watch my video about footage quality with the Mini 4 Pro, and don't forget to hit the like button if you found this video interesting.